In this video, I'm going to be talking about differential equations, specifically the situation where you have a rate proportional to a constant. So let's read through this question then. It says a new smartphone was released by a company. The company monitored the total number of phones sold N at time T days after the phone was released. The company observed that during this time, the rate of increase of N was proportional to N. Use this information to write down a suitable equation for N in terms of T. You do not need to evaluate any unknown constants in your equation. Whenever you have this situation where a rate is proportional to N, you can say that N equals some constant A multiplied by e to the power of kt, where t is time in whichever units are appropriate for the context. So in this case, they're talking about t days, but t could also be seconds or minutes or hours or whatever. Also in this equation, a and k are greater than 0. So let me explain why this is the case. Firstly, let's focus on this sentence here. It says the rate of increase of n was proportional to n. So how do we represent the rate of increase of something? Well, because you've learned about calculus and derivatives, you know that we say the derivative is the rate of increase of something. So the rate of increase of n we can say is dn on dt, the derivative of n. So literally the change in n with respect to time or over time. And if this is proportional to n, well, let's represent that mathematically. So we say proportional to n. And then if we want to turn this into an equation, we introduce a constant of proportionality. This is something you learn about in GCSE mathematics. We can say that the derivative of n is equal to k times n, where k is the constant of proportionality. Okay, so the derivative of n is equal to kn. Now we want an equation in terms of n, but we have a derivative here. How do we get rid of a derivative or reverse a derivative? Well, we take the integral, we take the antiderivative. And because we want this equation for n in terms of t, we want n on the left-hand side and dt on the right-hand side. So we're going to do a bit of rearranging here, and we're going to treat this derivative now as a fraction, which it is sometimes useful to do. So we'll take this n over to the left-hand side, in other words, divide by n. So we're going to have 1 on n on the left-hand side, and dn equal to k dt. So I've multiplied by dt. Next, let's integrate this equation. So we'll have the integral of 1 on n dn equal to the integral of k dt. So this is the integral of 1 on n with respect to n and the integral of k with respect to t. The integral of 1 on n, this is something you need to know, is the log of n. So 1 on something, the integral of 1 on something is the log of that thing. And we can add a constant on the left, but we're also going to be adding a constant on the right as well. So we might as well just leave that as log n. This is equal to kt plus that constant, which, you know, effectively includes the constant that we would have written on the left-hand side. Now we have a log n, but we just want n by itself. So to get rid of this natural log, we can raise everything to the power of e. So this would be e log n equal to e to the power of kt plus c. And e to the power of log, natural log of n is just n. And e to the power of kt plus c we can write as e to the power of c multiplied by e to the power of kt. Going back to your index laws, with the same base, you can add the exponent. So that simplifies to this. And then e to the power of c, that's some constant, right? E is just a number. C is another constant. So we just get some constant there. And we end up with n equal to writing e to the power of c as a. This is multiplied by e to the power of kt. So we end up with our n equals a e to the power of kt, where t is the time in days in this case. So that's the reason why when we have a rate proportional to that constant, we can say that that constant is equal to a e to the power of kt. And that's a really useful equation to remember because this situation comes up a lot where the rate of increase of something is proportional to that thing. So there you go. And also that's the reasoning why. Hope you found that helpful. See you in the next one. Bye for now.